Hello, sir. Good evening.
Hi, Chirag. Hello, Arun.
Hey, hi, Aaron.
Uh, Arun, you are muted.
I'm sorry. Yeah.
Yeah. Good morning.
Hi, Aaron. Good morning.
So, both of you have presentations and you will share from your end.
Yes, 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 yes.
Yes.
Shayon and Diptendu has also prepared. So,
For first of all, the warm introduction. I'm pretty sure the other panelists will reflect upon this, but it's a privilege to come back and speak at an opportunity like this. I actually wish I had these opportunities when I was growing up at ISI. Like many students who spend time at ISI go on to do different things in life. There are obviously very exciting moments in life. Having the birth of children, marriage, etc., are very big incidents. But I would say, I think many people will agree that the 5 years at ISI were the defining years of my life. I mean, it wasn't just a place where we got education. I think I probably grasped 10 or 15% of what was taught there and retained probably only 5% of what I grasped. So probably what I learned at ISI, did not stay with me in the form in which it was delivered. But what has stayed with me is, a way of thinking, a philosophy, which actually, underpins my, worldview and has helped and guided me through my career. What I wanted to do was talk a little bit about how, from my viewpoint, how I have seen organizations start to adopt data as one of the critical elements or things that underpin their success. I worked in traditional organizations for about 20 years. About 3 years back, I decided to go and join a startup. I was one of the very, not the earliest, but one of the early joiners of that company. We are 3 years into the journey. And part of what I'm presenting is essentially informed by that experience. Can everybody see my presentation?
yes.
Okay, brilliant. That's very helpful. So I thought the first slide should be about just my personal life and what I am interested in. I wanted to talk about, you can see this very dirty looking pizza oven and some bricks. I am a big enthusiast these days of DIY, and I'm trying to actually build my own tandoor oven. And the tandoor oven is going to be built with those 2 little pots you can see. So if I build it successfully, I will do another presentation on that at the next time we catch up. I grow potatoes and vegetables at home and flowers, and my daughter is one of my my assistants. She helps me a lot with that. Anyway, so that's enough about me. Let's move on to the topic that I talked about. So let's talk about building data-centric organizations. Because I work in a bank, my conversation is going to be very bank-centric, but hopefully the themes are universal and they can be expanded across to other industries. And even if you're not interested in joining a bank, this will be useful to you as you move to your life outside ISI. What I'll do is I'll structure my conversation around talking a little bit about banks and how they have evolved. There is a reason why I would do that. It'll just basically show why banks struggle with data as a problem, and then talk about how data is forcing banks to think differently. And I'll use the bank I work for as an example to show how we are reorganizing ourselves, actually building ourselves differently to make sure the data is available for use. So everybody knows what a bank does, right? Bank's job is to basically take money from people who have excess money, use that to provide money to people who need money, make a little bit of margin in the process, and thereby help the flow of money across the world. Banks are essentially facilitators who make huge amounts of profit. Banks started, long time back. Lending is a very, very old concept. It's not, it wasn't born yesterday. Banks, the way we know them, were born probably 6-7 centuries ago. And then in the last 3 or 4 centuries, we have seen acceleration of banking, not just in terms of the construct of banking, the infrastructure of banking, but also very deep lessons, through the Great Depression, when regulation became a part of banking. And thereafter, in the recent few years, what we have seen is the financial crisis, which then led to the birth of what we call digital banks, which I'm part of. Now, there's a reason why I'm going through this. So I'll come to that point later. If you look at the history of technology of banking, automation or computers, were introduced into banking less than 100 years back. Obviously, computers did not exist in current form 100 years back. But only in the second half of the last century did we start seeing things like automation scale up using computers. And then data became useful only at the later end of that piece. And only in the last 20 years have we seen concepts that enable organizations to leverage data fully. Stuff such as big data, things such as data mechanisms to capture data seamlessly, availability of hardware and software that allows you to do these kind of processes. So if I move on, let's think about what was the place of data in banks. And when I say the place of data, it also, by extension, is about the place of data scientists and statisticians and the tradesmen like us. What is their role in banks? So all banks start with customers at the center. They build products and services that they want for the customers. And then typically what they do is they build processes that can be used to support those products. So a process could be, how do you originate accounts? If a customer applies for a loan, how do you underwrite them? And that is a process in itself. You could have another process that is about how do you manage credit limits for customers, and so on and so forth. So a bank is, in some sense, you string together loads and loads of processes, and that's how a bank is formed. Banks organize themselves through functions. Typically, you'd have a collections function or a telecalling function that takes calls from customers. You may have a commercial function, you have a marketing function, you may have a finance function, a risk function, and the inevitable hamster function that just keeps running around, but it does nothing. But it's there in every single organization. And when you think about it, you can see that data doesn't traditionally play a role till each function realizes they need data to do something. And so then what they do, they go about building their own data organizations, their own data structures. And the further you move away from the customer, the further the entities are from each other as well. It's just the law of nature. And as a result, what happens is very large banks I've worked for, would have basically these data structures that sit independent of each other. So for example, customer calls in, you get the data in this blue box at the top left. Finance produces a report, the data comes out and it's stored in the bottom right. And these two never meet. And then comes people like us who can leverage this data to give insights. Once insights are good and useful, everybody builds them. Now, you'd say, what's wrong with this? This seems to work. This is how we come in. We think of ourselves as people who come in once everything is set up and the problem has to now be solved through data. The challenge is this. The problem with silos is that data doesn't connect. I mean, if data assets are not co-located, you cannot leverage them. And a simple example is this. A customer calls into the call center and says, can you tell me what is your rate for your loans? I'm getting something for 5%. I wanted to check if you guys have a lower rate. And the call center says, oh, sorry, we have 6%. Would you want 6%? The customer says, no, I've got 5% already. And he drops the call. That call gets logged. The next day, if I had that information in marketing, I would send a mailer out to say, you know what, you're a great customer. I can give you 4.5. Do you want that loan? But you can't do that because that data, as in the insight, is not connected. And therefore, the bank actually is operating as a disconnected entity. By the way, remember, this is not a banking problem. This is a problem that exists across every single industry that has got either a 300-year history or a 20-year history, because these were built in worlds when data wasn't that important. It did not exist in the quantities it does right now, and it did not play a big role in the processes they used. So slow analytical processes mean what? Customer dissatisfaction and therefore strategic disadvantages. And when I say strategic disadvantage, with respect to people who play well with data. So then the question becomes, okay, great. What if I could build it afresh? What if I had this chance, I could wipe out every single bank and build it again or build them again? And that's the chance I have been given thanks to this new banking industry, which is trying to build banking digitally. And because we had the chance to learn from the partial successes of our predecessors, we have imagined our organizations differently. So we start with the same exact story. We start with customers, we start with products, but then we start thinking things differently. So we say, okay, great. These are my customers. These are the products they want. These are the processes we want to service them. But let's make sure that we think data first. Let's not build those data sets that we talked about right at the end of the process. Let's build them first. And when we build them, let's build them with certain amount of intuition about it. So for example, customers' behaviors should link with this data lake. So an example of that, customer calls in, that call should enter the data lake immediately so that we can utilize that data next day morning to make a call. And that's quite important. But not only that, the product should also be able to leverage that data. So for example, think of a simple concept. Customers, if they have money, they'll save money at your bank. But the truth of the matter is a lot of young customers don't have money to save at all. How about you build a product with them that says, link your current account with me. I will use analytics to find out micro opportunities for savings, and I'll do the saving on your behalf. And that suddenly becomes an entry point into a customer segment that may not have 10,000, I'll say pounds, but let's say 100,000 rupees to spend, to save, but can build that over a period of time. And that's where data and the products can interact. But not only that, the processes can work with data as well. And I talked about the call. You can think of that as an example. If the call comes in, if you plant the data back into the data lake, you can utilize that the next day to do another process. But not only that, you also build your intelligence layer, the layer that uses data and converts that into insights to sit right at the center of the organization. And by which, I mean, you can think of models, you can think of, all kinds of, traditional models, modern models. I won't go into the specifics of it. The conceptual framework is that the data and the intelligence sits at the center of the organization. Now you'd say, depending, what's the big deal about it? Anybody can draw concentric circles, okay? I mean, it probably took you 15 minutes to build this slide. The truth is, this level of design, you can do only once or twice in the lifetime of an organization. An organization is not like a Rubik's Cube, which you can turn around blindfolded. You have to spend enormous amount of time thinking about what is the most important thing you do, because once you build them, they stay for decades. And that's why old banks find it difficult to transform themselves. New banks of today will find it difficult to transform themselves 10 years from now. So this is the time. And then when you build these linkages, you start getting into some amazing abilities. For example, I did not know that when it's a cloudy day, you get higher sales for a particular channel because people stay home. Now, that's something I wouldn't have thought about. It's kind of intuitive when I say that. But that kind of information could have only come through organizational structures like this. Now, where do I sit? Where does the data guy sit in all of this? Notice how come he comes to the center. And so in the new world, the data guy sits at the center of the organization. They don't sit in the periphery. So what are my takeaways from this story? You'll hear this a lot. Data is this new electricity. And it's true. Data is going to be the center of a lot of what it will be done in transforming this world, turning this upside down over the next 2 or 3 decades. But we, as a community of statisticians, data, educated people, we had imagined it already. We have, how many times we have bet, if you had the data, I'll show you you're wrong. That's our take on the world. And therefore, as the industry is catching up, they're preparing the stage, they're preparing their organizations for people like us to come and help them out. Our time is actually now. This is the best time to be a data scientist. It is the best time to be a statistician. However, remember one thing, we have to think ourselves differently. Remember the old problem where we thought about, or we were treated as the people who would come in once the data was made available to us, and our life was all about looking at the data and giving it meaning and passing it back? Our role has to be central. We have to be much closer to the customer in the new world. And therefore, we need to think about ourselves differently. And like everything, with great power comes great responsibility. So as data community, we'll have to think not just about how efficiently, how effectively, how smartly we use data, but what is our role in the world going forward. So one of the things I'd say to all of you is don't think of yourself too narrowly. Don't define yourself in just those terms. I'm a data scientist. Think about what it takes to be more than that. Think about how to think about strategy, how to connect with the world, how to understand the industry that you operate in, how to build relationships, how to get cultural understanding of working with different types of people, and other aspects of leadership that will come as you play more and more central roles in organizations. I say our time is now. And if you think about it, Edison was a scientist. In fact, electricity was the original electricity. And he built an empire from which I think we talked about Shandeb and I, we both worked at GE. So GE has been one of the great organizations of our times. There was a programmer who basically helped people connect across the world because guess what? Coding was that time. There was an engineer who's about to take me to Mars when I make my first million. So I think there's a time for statisticians now. Most of us have the electricity of our time available to us. We are best positioned to harness it. I think now the challenge is actually to you and to us to say, how do we use this moment that has been given to us to transform the world, not just stay on the sidelines, but get right into the center, be in the middle of the action. And again, like anything else, this will last 10 or 15 or 20 years. Thereafter, it will be time for somebody else to come and take over. So this is the time. Let's make best use of it. Thank you very much.
Thank you, Diptendu. That was fantastic. So we can take one or two quick questions now. If there are any quick questions or comments, or we can collect questions in the end. So
Hello.
I will just wait a few. Yes.
So thank you very much. This is Shamim again. My humble request to the Honorable Resource Person, sir, is that, sir, as a chartered accountant, as a Commonwealth scholar, I am working with the data for a long time. But unfortunately, just like the great statistician and mathematician, Honorable C.R. Rao, sir, once tell that your data is talking to you. Please try to learn to it and try to listen to it. Sir, I'm working with this data for a long time. I'm quite fluent in R and Python, and right now I'm pursuing CFA. But unfortunately, my data is not talking to me till now. Sir, I mean, what should be the way, what I should do so that my data, I mean, talk to me, just like it does talk to you, sir. Thank you very much, sir.
If I got the drift right, I mean, and I'll allow others to speak as well. Is your question how to use your data skills to achieve what you want to do? Is that what you're trying to get to?
Sir, the intuition I'm talking about. Actually, I'm a core business graduate, BBA, MBA, then MSc from, LSE UK, then chartered accountancy. Though I have a, postgrad diploma on data science from Bonn University, Germany. But unfortunately, as I'm working for a long time, really for a long time with data, but that sort of intuition is not coming to me. At times, my other colleagues tell me that, okay, you're not engineers like us. I mean, you are not a statistician like us. That's why it might be. But sir, I'm not satisfied.
So Shamim, maybe this seems like a very broad in scope. So maybe we can defer this discussion till the end because all the panelists may want to respond to this.
Might make more sense. Yeah.
Thank you very much. Thank you very much.
So if there are any specific questions targeted to Diptendu's presentation, then we will take that now, or we will move on.
Let me ask her. I have a question for Diptendu.
Sure.
Yes.
So Diptendu, banks are heavily regulated, right? So you have a regulator sitting over your shoulders, literally. Yes. So how, you also have to, control access to data to certain groups. So wouldn't that again go back and lead to silos and things like that?
It's a very good question, Arvind. So we are at Tandem, we're trying to use technology to do that. And what we do is we have very strong metadata conventions, which allow us to basically force some variables, for example, to be used for certain use cases only. So I'll give you a simple example. gender cannot be used, let's say, to decide on credit, or age in isolation cannot be used to make credit decisions. What we do is we tag those variables in our data lake in a way that we cannot. So when we build a model, the model has to have use cases defined against it. And let's say that model is about credit risk, then that model will not be able to pick these variables, for instance. The truth of the matter is this is a very complicated area because regulations are not static, they keep moving over time. But what we have done in our infrastructure is build it in a way that we can respond to changing regulations. I don't know if that answers your question, but that's kind of the broad approach.
Okay, that does. Thanks.
Okay, so I think let us move on to the second speaker. So the second speaker will be Chirag. And Chirag is going to look into the future of data and analytics. So Chirag, over to you.
Thank you. Let me know when you're able to see my screen.
Yeah, very good.
We can see the screen. You can move.
Yeah. First of all, thank you, Diganthaza, for giving me this opportunity to be part of this prestigious platform. And it's always good to come back to SI and talk to people. That's really a privilege, I would say. And also, like Dipendu also said, I concur. Like when we are in ISI, it helps us in defining like how we think. Okay, not about just like the program codes or some statistics. It's all about like how we see the world, how we see the problems in a different way. So thank you. I'm privileged to be part of it and happy to be here again. Okay, so with that, let's get started. Okay, so let me for this session, I'll just keep it as a story telling. So we'll start from somewhere where we are talking about the digital journey, digitalization. Okay, so approximately 25-30 years ago from now, where we are having limited amount of computer, limited computing powers, limited storage space, and also there are like literally very tough meanings to capture the data digitally. And we are saying, okay, we don't have data. And over approximately 2000, we started getting these things pretty available across. We have a lot of personal computers, and the digital things are also coming into the market. We started capturing the data. We started accumulating the data over the period of the time. And then after 2010, it started like, it's just a boom. Okay, so we are getting like a lot more data every day. And after 2015, when we are having this industry 4.0, all the machines are coming in. You have like your personal devices which are talking to internet. So you are just bringing a lot of data. So as a statistician or as a data analyst or maybe a data scientist, the coin has flipped now. Earlier, we have a problem like we didn't have data. Now we have a problem that we have too much of data. Okay, so now with that, I'll start my presentation. Now we have big data, what's now and what's next. So when we talk about the term big data, we started with this definition, which everybody is aware of, 3 V's of big data. It talks about the velocity, volume, and variety. And when we started with this definition, we are only looking at the data alone. Okay, so we look for 3 features: speed, type that we are getting, and what's the quantity that we are getting. Now, over the period of time, the definition itself evolved, and that's where the technology and the industry have something in constant. They keep on changing, and that makes your any technology infrastructure or any paradigm like make it very difficult to keep this stay. You have to always evolve. So over the period of time, then we added another attribute called veracity, becomes a 4V. Then we get it like the 5V definition, where we started talking about the value. Okay, and that's where the data-driven economy is started coming into the picture. Now, people have started working on 6 Vs, 7 Vs, at least till now, I am aware of 8 Vs. I don't know about 9 Vs, 10 Vs, whether they are there or not. But now people are associating different attributes to this data, because now they are also looking at the uses, not just the data alone. And that's where, as Dipendu also mentioned, it's all about how do we utilizing this data to take decisions. Okay, so now we have this data everywhere, and you have those different places where this data is coming from. Let's say streaming data that you're getting from IoT devices. You are having the typical ERP transactions, which is, let's say, the bank scenario if I take. And then you have a lot of computers doing many transactions, logging all these things. So you have like crazy amount of server logs created. Then you have media-based data sources, which are like your social media, then your Google Photos, those kind of things you are keep on pushing. And then last one is the social network data, which does not need any introduction. You are having trillions of data points created every day. Now, these types of data are very different type of data. So they need different data integration solutions, and you store them into a different databases. Or so far, people have actually stored them into different ones. So if I just take a one simple a few examples where right now they are residing, let's say in the relation database, NoSQL database. Some of them are going into Hadoop. For the analytical purpose, people are trying to build the data lakes and data warehouse, and also they are pushing it to cloud storage, let's say on the DynamoDB or those kind of available options that we have. So now the information is stored in this. So information itself is a data silo. Now I will talk about a problem beyond this. Okay. So far, we are talking about the data and the data integration. Now there are the applications right now available, which started talking to each other. Now you are having those integration points where application is directly integrating with another application. So let's say in this case, you have an ERP application and talking to a non-ERP application, talking to the third-party database, let's say weather data, all sorts of things. So all these things are creating different, let's say, integration requirement, more and more integration requirement, because now you are talking P2P. Okay, this creates the problem even difficult. Now, what people do, they started building those integration solutions, and you have like thousands of integration solutions available in the market, catered to one particular problem which they are doing. Now, if you see, on the first left side, if you see that you have the streaming data going into Spark streaming, creating an alerts in your systems, and maybe the example that you are getting from the transaction, you can take some kind of analytics out of it. Maybe you are processing your social network data with the GraphDB or NoSQL DB, then your logs with the Hadoop, then your then your typical ERP data, whether it's a SCM, CRM, or HCM, putting it to the data lake, data warehouse, or maybe doing a BI on top of it. And also there is the essential thing as a master data, which you are keeping across the entire ERP or maybe the other places where you want to integrate the data. So now the point is you are trying to process the similar data in different way for different purposes. And that's where what you do, you are creating so on the bottom side, you see these are the data sources which itself are siloed. You are creating the process data, which are again creating different uses. Okay, so they are again creating more silos. On top of that, you are having a lot of data integration, different type of data integrations, which there are many scripts are there, many programs are there, which everybody is writing, and they are keeping and processing the data and putting it there. What happens? It creates more silos. Okay. Now we'll talk about some of the solution, and we'll see whether they are effective or can they create more damage. So what you do now, you have so many integration options. Obviously, business users will not manage it. So what you do, you go to IT staff. You say, okay, they are already managing your source system, the target systems, integration tools. They'll also start taking your data integration jobs. They'll also run the data quality checks and try to see all the things runs very nicely, and the business user get the data what they are looking for. Now, the problem is if we do that, put everything on IT staff, it creates a bottleneck. Whether you are pushing this thing to the cloud, you can obviously offload something, but even in the cloud, somebody is doing your work. Okay, so what people does, okay, they brought something called self-service data preparation. They said, okay, now we have a data available. Now you can start building your own data pipelines, and you can maintain your own data quality rules, data integration rules, and then you can prepare, and whatever data you prepare, you can use it for your applications. So somewhat they try to offload the IT staff work to the people. You do on your own and the self-service. Now, in the earlier example, we see that people are creating the data and they are keeping the data to themselves in their applications. In the self-service also, now they have the power to do it. They are creating more and more data. So even for the trial also, they are creating many aspects of it. So what happens, we are trying to solve the problem of the silos, and we try to remove this dependency on the IT stuff. We end up creating more silos. Okay. Now the thing is, how do we bring all these silos together? Okay, so one of the attempt which already Diptendu have talked about is bringing them on a common platform as a data lake, and that's the thing that the industry is now moving on. They are trying to bring in. Now, you cannot bring everything to the common platform. Obviously, on the banking platform for the banking infrastructure, you for your own data, you can definitely bring it. But nowadays, the transaction is not depending on just on your data. You are having so many external factors coming into your decision taking. So you cannot just bring those data, or maybe you cannot replicate them into your system. It becomes a lot of challenge. Okay, so with that, I'll start with the first challenge. Like we need to bring the data together without physically bringing them together. Okay, so we need to have some kind of a common view, which at SAP we call it like the data plane, which connects to all the data sources which I want to connect, the data where I want to bring in, but I don't need to physically bring the data into my system. Okay, so things should be connected. Whatever in my organization I have, I would be able to manage it somehow. And like Dipendu said, it is not always feasible to do the transformation. Let's say for the older bank, they can never ever transform the entire thing into one single place. It is not possible. So what do they do? They need to think in some way where they can bring everything into one data plane so that they can have a single view of data. So from a business user, when I'm looking at the data, I don't need to worry about whether it's in my no SQL DB or the Graph DB, Cassandra, Hadoop. I don't care. For me, this is the data which is available, and I can use it as a seamless fashion. That's where we talk about the data orchestration. Okay, so data orchestration is even above the data lake concept that we are talking about. It's primarily a process where you include majorly three aspects. One is the data integration, another one is the data processing, and the third one is the business process. So data integration part is already explained that we want to bring in many different sources together, and they will be on the common layer. And the data processing is also best of the breed solution. You can bring in, provide them as maybe the drag and drop thing as part of a self-service tool into that particular data orchestration platform. You can bring in. Now, the third important part, which is playing a major role, pushing this data to take action. Okay, and those actions should be directly linked with your business processes. Okay, so like Dipendu mentioned, nobody will be analyzing this data manually. It is not possible. Okay, so when you get that phone call 6% and you are taking the decision, or maybe let's say you have a certain instance and then you see, no, we have a lot of people, we are putting at 6%, but market is going on 5%. I should be taking some decisions. So those kind of business decisions should be provided you as an actionable item integrated in your business process, so that as a CIO, CEO, you can take those decisions and trigger the necessary changes. So that's where this big process of data orchestration plays into the picture. Now, let me take the things further. From the time perspective, I am just keeping things short, so giving you the pointers to just a minute. Yeah, giving you the pointers like what are the different things and the thoughts that we have. Now, so let's take the example, you have bring those things on a common data plane. Okay, so now you have the data available, and this data now looks like on the left side. Okay, everything is available, dumped into one big data pile. It's available, but the thing is, you never expected it to be. As a system designer or data designer or the landscape designer, you never want this kind of a chaos or mess to happen. What you look at is this. Okay, this is what you want. The thing is, but this is not easy to achieve. Okay, and from just by bringing everything together into one common platform does not give me the right picture, although I was always wanting the right one. Now, so with that, there is a lot of work which needs to be done from from the left picture to the right picture. So now that talk about the second challenge, which is start sharing this data across organization level. How do we do that? Okay, how do we do that meaningfully? That's where we'll talk about the data marketplace, where we do the data discovery, profiling, semantic tagging, catalog creation, and most importantly, governance on top of it. So you will see the data creation has been present in earlier scenarios also. People are doing, they are doing analytics, they are creating that information. The missing piece was the governance. There was no governance. Everybody is doing their things on their own. So if let's say Diptendu has done something, I want to use it again, I have no way. I have to do it myself. Okay, and that's creating the more silos situation. What if Diptendu has a way to put that data somewhere and I can access it? That's where from the concept of the digital data marketplace, the business user, IT staff, data steward, analysts, they are creating the data. They are already having the data created from the systems, which is the raw data. They are processing the data, creating into the meaningful form, and they are publishing them to the data or the information marketplace. You can name anything in your organization, but that's how the concept is. Now, going forward, the application, the users will not always be talking to the raw data unless necessary. They will always look for the data or the information in that marketplace. So it's like going to the Amazon and asking for the data. Okay, can you give me this particular data? Now, so doing this is like saying it is easy, but doing it is very difficult. So it has like three major components. First one is discover. Okay, so you need to identify those different data sets available, the people who are pushing the data, and you need to set up some process where you can identify these things on machine. So that's where the metadata management is very important, and Dipendu has also have touched about it. If you maintain the metadata very if you make this metadata as part of your process business requirement in your landscape, what you do, you'll end up creating those tag data sets along with the detailed descriptions, also for, let's say, the columns or the features which you have in your data set. All those things you can capture. Once you have that, now the things can be made available for others, because now they can understand like what this data means. On top of that, if you provide a governance, providing them obviously the tools to do the transformation, and you do monitoring, like who is uploading what, how much is being uploaded. And once this curation is done, you can actually do the indexing on top of it, organize them into a library kind of a setup, and publish it for the public. So once the data is available in this form, which we typically call is like unified data catalog. Now, we need to consider one thing: the data is still there where it was. Only the catalog is centralized. So like Amazon, you are just looking, everything is there, but Amazon is not selling it. Someone behind the scene, the seller is sending you that. So that's exactly same thing we want to bring in here. So now with that, once you have all these things labeled, you can do multidimensional search. You can find out what you're looking for. Now, not everything is good. Okay, so you have created it, you have fantastically provided a search engine and everything, but how? So let's say Diptendu has done something. I am also using the data which Diptendu have shared. I am using it. It's very wonderful. Now, how does Arin know that this data is good? Okay, so we should be having a mechanism to provide the feedback and the rating like we do on the product for the data. Okay, once you have the feedback and rating provided on the data, now Arin knows that tend to have some work, and Chirag has used it. Given the rating is good, I should also use it instead of doing this thing again. Now, the thing is, so far it's fine. Now, Arin has also fine. Okay, let me not do that. So you have saved some of the silos, some of the data processing, which he has to do. Now, Arin is working on a bigger use case where he need to bring in the additional data source. So he took the data set which was created by Diptendu, also created the data source from third party or whatever data another data source have, and does some kind of an transformation. And also now now he has like a more valuable data set available. Now he will definitely push back to the unified data catalog so that make it available, and that makes this collaboration and make working things in collaboration, and also you are enriching the data which Diptendu has shared. And when I'm talking about the enriching, you're not just enriching the data on the columnar or the row level, you are enriching the data on the semantic and the context level. Okay, so unless you update that metadata and you talk about like how these things can be used, your search engine will not be able to pick. So that has to be done. So these are the four main features which people or the main topics which people are nowadays focusing on, and in futures you will see the bigger bigger platforms coming in which are talking about this. Some of the things are already available right now in the market. Some of them are still in the discussions or in the development, which is available. Yeah, so one more, I'm almost at the end of my session, so I would like to give the food for thought here. So now let's say you have all the metadata available, you have the description, features, everything available. Now somebody is doing search right now, you are providing the inputs to them, providing the data assets to them. Now, what if somebody do a search? Okay, I'm looking for this thing from this direction to this particular duration for this particular features, and you provide say proper description which you are looking for in your business term. Now, since now we have a capacity of AI ML to do the connection. So even that in the discovery also, people are now using AI ML to identify the common data sets, tagging them together, making it a larger view. So you can start doing those kind of things. And what if I give you that pipeline which you are supposed to create in the self processing tool or self data preparation processing tool, the ML or the AI can directly build it for you. Now, I'm not talking about building the data and giving it to you. I'm talking about the building that process for you, so that now you can and take care of that particular process. 70-80% of the things is done. You find out, fine tune it, and now you have a newer data set ready, which is available for you, or also going back to the unified data cloud. Okay, so that's what we are thinking. Hopefully, in a couple of years, we will be seeing these things live, and the speed that we are like changing our landscape and the newer technologies are coming in, who knows, we may be having even newer paradigms coming in. So with that, I'll just end my presentation. Thank you so much for joining.
Can you give an example of metadata?
Okay, so from the metadata perspective, you are you're tagging those data. So let's say some of this crude example, if I take from the banking itself, you are talking about this, let's say transaction data, what kind of transaction data it is. Okay, then you if you are going on to the row level, and if you are going to the columnar level, you can create set of certain columns and assign that particular set as let's say it is like the personal information. Assign it as, let's say it's a credit information. So like that, you start tagging it. And like the thing you mentioned, with this metadata also provides you the greater amount of security and the governance, because then it helps you, this personal data, let's not use it for making any decision on approving or rejecting anybody's loan.
Thank you.
Okay, so in the interest of time, let's move on to the next panelist. We can collect questions in the end.
Yep.
So let me now invite Shayandev Banerjee, who is going to talk about the reverse problem, analytics when data is sparse, and how business problems can be solved beyond statistics or mathematics. So Shayandev, over to you.
Shayan, you're on mute, I think.
Shayan, you are on mute.
Yeah. So sorry about that. Okay. So the same thing had to be repeated twice for me. Thanks everyone. I know Chirag has taken us to few years down the line, maybe 10 years. I don't know, Chirag, what's the timeline you're talking about. What I'm going to do, I'm going to talk about some of our really ground realities and challenges. So I want to bring all of you down, right, to where we are today, to solving business problems, and essentially not even talk about sparse data as much. I'm going to mostly talk about some of the challenges that you have to be, and this is mostly for the audience, that while we learn a lot of things around statistics, mathematics, whatever disciplines you're studying, computer science, when it comes to real business problems, there are some more, there are these bouncers that come from different sides that you need to be aware of. So without taking more time, let's go into what I'm talking about. And as you said, I'm talking about looking beyond algorithms, kind of when you talk about your real business problems. Okay. So what does not meet the eye? This is the summary of kind of what I'm talking about, and I'll try and give a few examples that I have encountered. I'll probably take a couple of even industry famous examples, but I think examples will help make things better for all of us, right? So what we study when kind of I was in ISI quite a few years back. Chirag has been kind of still more recently, but when Diptendu, me, and others kind of that there was a long time back. But what we study, and by the way, those are all so important, right, for everything that we do today, right? All the applications that we create, all the problems that we solve, we kind of study about importance of estimates, kind of all the margin of error. How do you deal with that? Are you creating the right confidence intervals, standard errors, all your p values? Are you testing the right hypothesis? Is this the right way to test the model accuracy, so and so forth, right? I mean, depending on what discipline you are in, I just gave a few examples of what we study. And why I'm saying what we study is I want to contrast it with when we practice the science that we have learned to solve real problems, the things that become, I wouldn't say more important, but equally important, and many times get ignored by some of the best talented data scientists or people who are really good in the stat and the math and the algorithm part of it, but get missed out, and therefore kind of lose that sit at the center that Diptendu was talking about, right? Where you need to get the sit in the center and really think through the business. What is this business about? How can I solve this problem? And so what are those? It's not about the problem formulation. What is the problem that you're going to solve? Yes, kind of you need the right data, you need the right algorithm, all of this is fine, but are you formulating it as a right problem? And we'll see some examples. You obviously have to think and spend a lot more time on data quality, and kind of Chirag kind of started talking about how things are being made, I would say, easier, or not easier, kind of more in the hands of the users, right, to make it happen over a period of time. There will be challenges of data ingestion, data transformation, because you might build the best possible algorithm, but if these are not sorted, if these are not solved, that will only remain a nice piece of algorithm, a nice piece of code that I'll kind of have to probably just put in the GitHub, and it will not see the light of the day. I have to explore the data in hand and learn a few very basic things, and many a times people miss that out. Model selection. Now, when I say model selection, I don't mean the appropriate selection from a statistical or a mathematical perspective, but I'm saying model selection from pardon the typo. Basically, I mean the black box versus white box consideration, right? So there are areas where, though I know model or methodology A is the best one, it will give me the best result, I have to choose methodology B because it is probably more explainable, and sometimes explainability becomes far more important than your ability to predict and things like that. And I'll see a use case on that. How do you evaluate a model in a business scenario? Not in terms of just the estimate and the power of the estimates, but is it kind of making sense? What does it translate for the business user in terms of that, the business relevance that I talked about, data storytelling, explainable solutions. So there are a lot of these features that I've seen through my experience over this last so many years, that becomes so much more important, and some of that can make your your solution, the algorithms that you're building, the models that you're building, so much more critical and valuable. We talked about the fifth V. I think Chirag, if I'm not wrong, the fifth V is the value that is getting attached, but how do you really bring that value? So let's look at a few examples. And first of all, I've tried to at least dumbify these examples or simplify them so that kind of I don't get into the depth of some of the business challenges. So if it sounds too simplistic for some of you, pardon me, but I'm sure this will give you the sense of what I'm talking about. Okay, so select the right problem to be solved. I talked about problem formulation becomes very, very important, not just about the algorithm. Um, this is when we are working for one of the largest casinos. So the stakeholder, kind of that we're working for is responsible for revenue management. His ask was very simple, that we have 3 memberships for our consumers. They call it bronze, silver, and gold. Can you design appropriate marketing offers to engage them? Right, very straightforward ask. We went ahead and did kind of a lot of good work. $5 million was spent for the marketing, right, to in order to bring all of those outcome that we created and all those recommendations to the table. But the project kind of resulted in a loss. In a sense, it never created the kind of impact that it was supposed to create. So when we kind of dive deeper into it, and this is post factum, by the way, most of these examples that I'm talking about are real examples. So it happened to me, or it happened to my team, and we learned kind of the hard way. So we obviously burnt our fingers. So I thought it's better to share some of those examples where you burnt your fingers. So as you can see, right, the biggest challenge that we had, that the so-called gold customers kind of was only 1% of the base. You remember I talked about just exploring your data a little bit and learning a little more. Probably we missed out on doing some of those. And because it is only 1%, anything that you designed overall from the data, kind of in terms of more mass marketing offers and things like that, was not so useful. So what was clearly needed was a more hand-picked custom approach, and therefore we needed to scope out the problem much better and the potential solution before building our kind of very fancy algorithm. So again, the lesson learned is that kind of try and understand the underlying data a lot more. Try and see that if you're solving the right problem, and then go ahead and build your statistical models or whatever mathematical models that you're building. Defining the problem clearly. This is for an insurer. This was for an Australian insurer, and their complaint was that my portfolio, that is kind of my total portfolio, number of people that has bought insurance from me, is not growing over a period of time. There was a strong perception that they are overpriced, right? So when you buy insurance, you have to pay a premium. So they strongly believe, I think based on some research also, that please revisit the pricing to make it favorable for acquiring new customers, right? Because I'm not growing, so you need to do that. Traditional approach, kind of you heard the problem, you just went ahead, started solving the problem, built fantastic state-of-the-art pricing models, algorithms, and ultimately they were not leveraged, right? They're not even used. Why do you think that was happening? Because again, when you go a little deeper into the data, you realize that pricing was not even a problem. New customer acquisition was never a problem. The portfolio has increased attrition. So people are not, it's not that people are not joining, even with their pricing, enough number of people are joining, but they have a leaky bucket. So people after join, and this is a health insurance, so you can change your insurer over a period of time, nothing stops. It's not a term policy that once you take it, you generally try and continue with that. So people were attriting and kind of was far higher than industry average. So you obviously need to see what's wrong, why are people leaving. So it's not a pricing problem, it's probably for a claims problem. People are probably not satisfied with their claim experience, probably not happy with their customer service. Maybe kind of there is somebody else which has come in the market, so there could be multiple things. So it was more of a retention problem. How do you keep your customers with you rather than an acquisition problem, right? So again, the point is, how do you formulate a problem right? How do you look at the underlying data to understand what is the real problem, and not just based on what others, or sometimes when people like us who are more like providers and consultants that work with customers, and I'm sure Chirag Orin can understand that better. Diptendu is on the other side of the chair, at least as is right now. But when your customer says that this is my problem, there is a tendency, okay, I'll solve that problem, right? Because I know my kind of my trade very well. I know my statistics well. I understand this data, so I'll go and do it. So why do you need to stop and have a look? Okay, all of you are very familiar with the Netflix challenge. I'm sure most of you have heard about it. Netflix kind of had a challenge running for a long period of time, trying to say that they have multi-million dollars kind of award for people who can build the best recommendation engine for them. The recommendations that you see, right, when you log in if you have seen this movie, based on that, you see a bunch of recommendation. So for the best recommendation engine, they declared a big prize. So they also declared a winner, by the way, built an ensemble of algorithms with, a lot of effort that has gone into it, with an improved accuracy than what the existing, kind of the recommendation engine had. So all great, right? And the winner won a big prize, so on and so forth. But the reality is, I don't know how many of you have followed that or tracked that Netflix never implemented that fantastic solution for which they opened this, kind of large open competition and paid so much of dollars, right, for that. So the reason why they could not, or rather, implement the real solution that was proposed was that was not really production ready for a live recommendation. It was a great methodology, but using that method and the way it worked, and I'm not going to go into the details of what method, why it worked, why it didn't work. But the point is that if you have to do a live recommendation, right, I mean, on a real-time basis, you probably need to use some other methodology which will run much faster and kind of in some nanosecond, split seconds. But this was not, given Netflix's, kind of volume that we are talking about, it was not, feasible. So understand business need, and more importantly, understand the constraints of where this will get used, how will this get applied, what is my, kind of data flow, where will data flow in from, how will this algorithm be powered in the real life. So sometimes those are far more important, and the reason why I am telling this to all of you guys, kind of sometimes you're too focused on building that best possible algorithm, winning that prize, without really asking the question, will this ever get, really implemented? Will it see day of, light of day? Sometimes it doesn't. So that's the problem. Focusing on business outcome, right? So, we want to understand our, the problem statement that, so the problem statement that we are dealing with over here is that, we want to understand our demand and forecast better, right? This is from a retailer, like the Walmarts and the Targets of the world. One of them said that we want to understand our demand and forecast better. Very, very straightforward demand forecasting problem. I'm sure whoever has, kind of done work around time series will jump into it and start solving the problem. So there was a very, very, kind of rich, complex model that was built with great deal of accuracy in forecast, but was not used by the business again. Let's see why that was not used. Because, in this situation, again, don't generalize it. In this situation, for this retailer, the particular, stakeholder or the client that we are working with, for them, more than the accuracy of that forecast, the explainability of that model, to understand the drivers of that demand, was far more important. And obviously, a neural net model that was built is not going to give you, kind of what are those drivers or explanatory, kind of variables. At least the model that was built in this case was not built in that fashion. Now, that is a discovery or an understanding that should have been established right at the beginning, because it was not about that perfect accuracy. Everybody wants higher accuracy. Who will say no to it? But more importantly, they were very clear that unless we understand that why you're saying that my forecast will be X units, right? 500 units, whatever you're saying, what is driving it? If I change some of those things that are in my control, right? Will this demand go up or will it go down, right? If I can produce more, then, kind of will I be able to sell more? Those kind of questions were far more important to them, because the people who are going to make a decision on the production to meet that demand clearly are not convinced if you give them just a number saying that, okay, produce X units, right, and done. So it never happens. So the outcome explainability, in this case, I just said regression models, but whatever, any of those model construct that will help you to explain, kind of why you're saying an outcome is far better than any of the other models, which at least come across as a black box to many of the business users. And this is a problem that we face so many times, right? That you build the best possible solution, business or the stakeholders who are going to use it is not happy because they need to understand, kind of, and explain, why something is changing. How will the business use the solution? You have to ask that question upfront. In case this is a bank, coming back to where we started from. So we have to identify fraudulent transaction. This is, credit card, lot of transactions happening across the globe. We want to identify, kind of which of them are likely to be fraud or fraudulent transactions, so that the kind of whoever are the fraud investigators can really do an investigation and then verify that. I'm sure I don't know if any of you while using your cards would have probably got some notifications like this if you have used it in the wrong manner. Now the traditional approach, the problem was great. In this case, obviously there was not so much need for explainability as well, because as long as I can more accurately predict the likelihood that that this is likely to be a fraudulent transaction, then I can obviously have to get investigator investigated. My model won't be the end of it all. So I have that liberty. So a lot of research was done for a long period of time to generate the the best cutoff value of the threshold, and you can relate to it very well. Why I am trying to get the best threshold? Because I don't want all transaction to be investigated. That will be a disaster. I don't want kind of too few to be investigated, because then I might be basically how wide you want to cast your net, right? That's a big question to be asked. But in this case, it was the solution was right there. It was not that difficult. The challenge was that the current team, that whoever will be implementing it, their ability was to inspect 25 cases per week, period, right? Yes, in the future they will increase capacity and they will be able to investigate more. That's for the future day. But as of today, they can do only 25. So I put in a lot of effort, put the right threshold and say this 63 cases needs to be investigated. And guess what? They can only do 25. So why kind of put in those a lot of interesting effort and kind of put in, and by the way, this is again sounds kind of like I've created it, but this was the case with one of the I thought this was an European bank or somebody in Asia bank. I forgot which one, and like we were really saying what were you doing all this while? So understand the constraints that you need to, while deploying your model, while using it, kind of what happens. So that's pretty much kind of a few examples. Hopefully that will illustrate. I didn't want it to take a lot of time, but I think you got the big message that while we learn a lot of good math, stat, whatever it is, but when we apply in the real business cases, there are many other things that become far more important. And as I said, kind of these are the lessons learned. So thought I'll share with this group.
Okay, so the message was quite clear. And as usual, Shayan has made a very deep presentation. So are there any quick questions specifically on Shayan's presentation?
I'd like to make a comment that was spot on, and actually it corresponds exactly to my experience in the industry, especially the retail one. Because in retail, they're essentially trying to get price elasticities because they want to make pricing decisions and things of that sort. So if you give them a black box model, they're not going to be happy.
Sure.
And I think this was an excellent presentation.
That's everywhere. I'm sure you have seen that. All of us, whoever has practiced, that's what my point. Whoever has practiced with real business problems have seen some of these challenges, and it's not about the best possible algorithm. Okay, I think let's move on. I'm eager to hear what Orin has to say, and we are clocking on time. I think we can take questions at the end, probably. Hopefully, we have time.
Yeah. Okay. So I think Shayan is right. So let us move on to the fourth presentation of this panel, Orin Choudhury, and he will be talking about some cutting-edge data analytical techniques. So Orin, over to you.
Orin, you're on mute.
Orin, we can't hear you.
Sorry, I made the same mistake again. So, okay.
Pandemic.
Can you hear me now? I assume
yes,
you can.
Of course.
Yeah. So, so I'm going to talk about some common themes in IoT data analytics. So you would have heard, this jargon that we are in the age of IoT. And what does it even mean? When I was in my early years in USA, the place where I was living in, so in USA, houses are made of wood, and they're heavily carpeted, which makes them a fire hazard. Unlike India, where houses are made of concrete and brick. And once, where I was living, the ember from a agarbatti fell onto some inflammable material on a carpet, and the fire sensor saved us because the smoke alarm. And because it was continuously monitoring for the presence of smoke, and if it had not worked, alerted us, we would be in trouble. So sensors have been used for a lot, but things have changed. Sensors are now cheap and they're much more powerful. Technology has progressed. They're much cheaper. They can now save the measurements. So sensors are essentially measuring something, and then transmit them to a remote computers, which is the fancy word for that is the cloud. So with the help of these sensors, we can monitor a lot of things. We monitor windmills and other industrial equipment, even agricultural conditions, animals, and all that. And now these sensors generate a lot of data. The data can be potentially useful to anticipate problems, and we can react to problems well ahead of time. Hopefully, that's our goal. And if we have, and statistics and machine learning will play a critical role in exploiting this data. So, but as Shan said, that you might have a lot of data, but is the data useful? That's another topic. So there are a lot of we have some challenges with IoT data. We are sorry, it's for some reason it's in automated. So I'll just do it in this way. Sorry. So there are a lot of variables, and they're in high frequency, and they have a lot of missing values, because you will see there are protocols that sometimes you don't get a value time, you just send a garbage value or a missing value. And then these equipment, these sensors, they have only limited memory. So, and you want to save some data, but you can't save all data, because you will have too much data and most of it will be useless. And you have to determine how much data you have to send back, how much you have stored. And in this huge volume of data, you are looking for some tiny bits of information. Another big problem which we face is data is heavily imbalanced. What do I mean by imbalanced data? When you are measuring the state of an equipment, especially if it's a very reliable machine, overwhelming majority of the data will describe the normal working condition of the machine. For example, consider your air conditioner or your refrigerator. They really go wrong. And if you want to predict a fault from this data, where you rarely or almost never, you have never seen it go bad, is clearly a very difficult challenge. So these for these, for this, the IoT data, these are the common themes, in my opinion, of what's happening. What we want to do with this data is first anomaly detection. So when you are generating so much data, one of the most obvious things you can do with it is to alert someone if something is going wrong. So that is where anomaly detection comes in. Anomaly detection is essentially just a generalization of the statistical technique of outlier detection, but it's a little bit more general. Another problem which comes across quite frequently is dimension reduction. So the data we get from sensors has a lot of redundancies. For example, if you just decide to monitor temperatures 20 times a second, 90% of the observations you get is going to be redundant, because you're essentially going to get the same readings 19 times out of 20. But there's another redundancy. Sometimes you're measuring a complex machinery, and you have all of these sensors measuring a lot of different things, but they're highly correlated with each other. And you can effectively reduce the dimension by looking at some combined features and working with them. Another things we have seen, which are very commonly which occur in IoT data analysis, frequency domain methods. These are traditional methods which mostly electrical engineers use, which are Fourier transforms and digital filters. So I'll talk about some algorithms which we have found to be interesting in for each one of these domains, and I'll go over them one by one. So what is the central problem as I said, I already mentioned, what is the central problem in anomaly detection if we are measuring something and if it means anything? So let me why won't traditional methods work so well when we have to do anomaly detection on industrial monitoring data? So one of the biggest problems is the data is multivariate and multimodal. By being multimodal, it means that if you assume common statistical assumptions like Gaussian, they don't apply. Also the relationship between variables is non-linear, which also makes standard application of standard techniques quite difficult. And as I mentioned before, data tends to be imbalanced because they're all describing the normal state, and we cannot make any sort of strong distributional assumptions. So one of the methods which comes useful is something known as support vector data description. It is based on a very simple geometric idea, but it's so in its simplest form, what it does is you have, assume this data, these blue dots are represent the sensor readings of the obtained from some reliable equipment. So and we want to know when things are going strange, and we only have normal data. So what we do is we try to build a circle, a simple circle which contains overwhelming majority of the data, say 99% of the data. You can choose a threshold. Then a simple way to detect outliers in this scenario would be to look at the distance from the center of a particular point. And if it's outside your radius, which is the threshold you choose to contain most of the data, you can call it an outlier. But this approach has a problem. So if you see, you can have shapes which really don't, the geometry doesn't correspond well to a circle. Now, even if you fit a good circle which contains most of the data, you'll see this circle has a lot of empty space. And this empty space means it will be telling you, it will fail to detect many outliers. We want a kind of, instead of circle in this case, we want to fit a surface around this data which contains most of it and corresponds to the shape of this particular data set. So, but there is something in statistics, in machine learning, known as the kernel trick. So the kernel trick essentially involves, if you mathematically, replacing your inner product with a kernel function. But intuitively, what it does, it essentially maps data to a much higher dimension. And you are essentially analyzing the data in a high dimension and pulling back what you see down to the dimension on which you observe your data. So this is what it allows us to do. You see the white dots here are, again, our normal operating condition data. And we have you see a blue boundary with blue dots. And this is actually the effective boundary. So what happens is we have deformed the circle using a nonlinear transformation to correspond to the geometry of the shape of the data. So this circle has been distorted to fit the shape of the data. The center now is somewhere in the middle of this shape, and the contours show you essentially the distant points of the distorted circles at a certain distance away from the center. So essentially what you have effectively done, you have done some nonlinear transformation, and you have generalized the concept of a circle to fit to something more general. But these kernel trick has some other applications. So for example, you have data. For example, when you have data from a car. The car runs in multiple modes, in different gears, and the data, all of them represent the normal working condition of the car, but they look different. So here, if you see, when you fit SVDD to the kind of data you see here, it somehow is smart enough to figure out that internally there are two different disjoint regions of the data, and the surface it fits essentially two surfaces around the disjoint regions, and the points the red points you see between these two surfaces are now also considered anomalies. So this approach allows us to handle data of different sorts, especially when there are multiple operating conditions, which is very common with, for example, in this particular data, this is NASA turbofan data where we applied. I'll show a practical example of this method. So we analyzed NASA turbofan data, which is a simulated data set simulated by NASA on 218 engines operated under failure. Now, traditional methods find it difficult to analyze such data because this data has multiple operating modes, and you have to handle them well. So what we did, we took a small subset of these 218 engines. We assumed the first 25% of the data represented a normal working condition, and we fit SVDD on the small subset of engines, and then we scored the what we got on different engines. And let me show you the result of that scoring. So these are arbitrarily chosen 4 engines from the holdover set, and the graph, it shows across time. So as I said, we have in SVDD we get some generalized circle and a measure of distance from the center of the circle. The further you are from the center of this generalized circle, the more anomalous your behavior gets. Now, what you see, if you see this, so these things plot the distance from the radius for these 4 engines, and you can see as time increases, you can see a sudden degradation near the end of the lifetime of the engine. And what this means is it is possible for you to set thresholds, and if you see your distance measure moving beyond a certain threshold, you can generate an alarm and alert the maintenance crew and say that there's something wrong, please go and take a look at that engine. So these class of methods in general are known as one class classifiers, and they're especially useful when you really don't have observations from both failures and normal working conditions. So the next problem which comes, as I said, I already said why dimension reduction is very important in the machine learning context. I'm going to talk about a very specific dimension reduction technique, which is a kernel PCA. So principal component analysis, as we know, is probably the most common, one of the, if not the most commonly used statistical method after regression, one of the most common. And one of its common use is to get 2D or 3D visualization of high dimensional data. So you take a high dimensional, you have diamond data, you get a 2D view, then you can plot it and you can try to visualize it. So KPCA, kernel PCA, is a nonlinear generalization of principal component analysis using kernel embeddings. This is essentially the same kernel trick I was talking about in my in SVDD. Intuitively, it essentially maps data to a higher dimension, does things there, and then again pulls back the result to the lower dimension, and you get you get a better view of what's happening, especially when they're nonlinear. So let me give start with a toy example to motivate why this might be useful in certain contexts. So what we have here is it's one of the standard data sets. It's known as a 2-moon data. So the data set on the top left is the original data. You see it's in the shape of 2 loons. And now since it's 2-dimensional, if you do the usual principal components analysis, you'll essentially get back the data up to a rigid motion. And if you see and we also show the kernel PC output, because kernel PC is mapping it to a certain high dimension and getting the first 2 dimensions back from that high dimensional mapping. And if you see, kernel PCS clearly separated the two lunes into two distinct areas. So the blue, one of the lune maps gets mapped to a blue line, and other gets mapped to a some sort of a semicircular shape. But they're clearly they have been made distinct. So you can sort out the nonlinear patterns in this. While as is expected, if you do principal components analysis, you just get back this original result just back. So what is a practical application of this? So what we did was, we are trying to understand vibration data. So what we did, we have this machine in SAS where we have a motor with accelerometer, vibration sensors. So what we did was, we ran the motor for 10 minutes under normal conditions. After 10 minutes, we induced a fault and then measured the state of the machine from this, continued with our measurements. And of course, we want a method which will be able to tell us whether we have whether there is a fault at a particular point of time. Now, what we did was, we looked at this data, vibration data, and we reduced it to 2 dimensions using kernel PC. And this was one of the many things we tried, but the result was so striking that I decided to share it with you. So if you see this graph, so the blue dots essentially they are the data from the normal working conditions. So if you see, there's a small 3 blue regions. So you see there are multiple operating conditions here also. And what happens, you see these red spirals coming out of the blue dot. So if I wish I could have shown you an animation, sometimes it doesn't work well with PowerPoint, so I didn't I didn't use it here. So what happens is, initially when the machine is in the normal conditions, you could see that everything is everything lies in the blue dot. And around, after the machine goes, the fault is induced, the blue spirals shoot out of these red blue spots, and they move all over the place, and they give a very powerful visual representation of something having gone wrong. And this has, after that, we have used it. It has a part of our tool set and has proved itself useful for analyzing a lot of different kinds of real data we have encountered. Finally, I'm going to talk about Fourier transform. So these are very simple techniques, and these have been around, especially used by electrical engineers and all others for almost close to a century maybe. And so Fourier transform, essentially the core idea is, those of you who have taken course in time series analysis know that time series are usually analyzed in 2 modes. One is in the time domain and another is in the frequency domain. In the frequency domain, we essentially try to we imagine the time series, especially if it's a stationary time series, is a sum of sinusoidals, and we try to weighted sum of sinusoidals, and we try to understand the through this representation, we try to understand what's happening in the time series. But if your time series is what is known as trend stationary, that means it doesn't have a trend in it, but it's still non-stationary. One of the useful methods which for analyzing such time series is short-term Fourier transforms. So essentially what the short-term Fourier transform assumes in that over a short period, your time series is approximately stationary. And then you essentially do a Fourier decomposition. You divide your time series into multiple overlapping windows, and you do a Fourier decomposition of these time series. And the change in the nature of the Fourier weights tell you a lot about the time series. This kind of analysis is especially useful for any type of signal which involves sound, vibration, and things like that. And it is also very useful, we have seen in many cases, as providing features to more complex machine learning models. And I'll finally end with a very simple application of this, which makes its use obvious. So, for example, what happens is, so the output of such short-term Fourier transform is what is known as a spectrogram. So this is a spectrogram. So let me explain what this plot is. So you have time and you have frequency in the x-axis and you have frequencies on the y-axis. And the colors at a particular point tells you how much weight the time series, how much weight of particular frequency has in that particular point of time. As you can see, the more blue, the less, that is how little weight it has. The more yellow, the more weight it has. And you can see for a normal heartbeat, it's very rhythmic and frequencies lie in this range. But what happens if you have a heart murmur? You can see that there's much more energy in what are the high frequency ranges starting from 200 onwards, where in the normal heartbeat, you can hardly see, there's hardly anything above 400. But here you can see there's a lot of weight has been transferred to the regions in the frequencies, high frequency areas. And just by taking a visual look at this output tells you that you can differentiate between these two and possibly alert about a heart condition. And there's another, especially in today's COVID era. So you can possibly detect wheezing from spectrograms also. Here the examples are a little bit more subtle. So you have here the spectrogram for a normal breathing data, and on the left and on the right you have a spectrogram of someone who's wheezing. But here you can see on the wheezing, if you notice carefully, that you will see a little bit more weight around between 400 and 600, and that actually allows you to differentiate between two and identify wheezing. And it's only not in this, and there are other techniques I'm not talking about related to Fourier decomposition, which is especially an area known as digital filters, which we have found to be extremely useful in analyzing the data we come across. And it is used a little bit in econometrics, but not that much in the mainstream statistics. But I think it makes sense to make it a part of a mainstream statistics curriculum. And actually that's it from my side, and I'm done.
Okay, thank you, Orin. It was very insightful and very nice analysis too. Right. So now we are open to questions, in particular to Orin or to any of the panelists.
Hello.
Yes.
So thank you very much for allowing me. This is Shamim. So the first question actually I requested from Honorable Resource Person Sir on the very first actually. I guess Sir provided his lecture to us for this session.
Yes, so we are in the process. We will make this available in some form, and we will let you know.
No, I'm not saying that, sir. I'm actually requesting that as I requested the first question to
Okay.
Honorable Resource Person Sir of this session. I think the name is.
Hi.
Yeah. I
yes,
think he's
yes.
asking the question.
Professor
Like, how
Dr.
can
Diptendu Khan, I think.
Yeah.
Yes.
Hi.
Yes.
So Shabir, I'll be very honest with you. I probably did not fully grasp your question. Do you mind helping us and perhaps?
Sorry, sir. I'm really sorry that I was not actually able to, clarify the question properly. Sir, my humble request to you is that from the very first year of my university, I'm talking about the BBA first year. Since then, actually, I'm working as a research, assistant. After that, I worked as a research associate. I'm actually working with the data for a long time. But unfortunately, as Honorable Professor Dr. C.R. Rao once told, that your data is talking to you. Please try to listen to it. So working with my data for this long time, but still my data is not talking to me.
Okay, Shamim, I think that comes with experience.
If you want to dig into that, may I answer?
Yeah, of course.
Yeah, thank you.
Thank you very much, sir.
So Sami, let me be a little philosophical here. Okay. So when we talk about like the data is talking to you, and you will see the data have many aspects, and it is sending so many signals to you, and the listening is very subjective. Okay. So I'll take the example from the Sandeep's presentation. If you define the business process or the problem which you want to solve, then you will find out the right vibes coming from the data. Okay, don't try to see like you have the data now, what can I do with it? Try to see I have a problem, how can I solve with this data? Then this listening will become more easy. And as sir mentioned, obviously the experience will make you better at it.
Thank you very much, sir. Thank you very much. I mean, it's a life lesson for me. Thank you very much, sir. Sir.
Other option, Shamim, is why don't you collaborate? I mean, when data doesn't speak to you, find out somebody else who can help you. Perhaps, this is like any conversation, right? You always perhaps have a better adda with more people. So maybe getting a couple of more other people might help.
Sir, unfortunately, the fact is that I actually, shared this problem earlier, I think, as I'm a core business graduate, BBA, MBA, then MSc in econometrics, then chartered accountancy. So unfortunately, my colleagues, actually, my fellow colleagues who are engineers or statisticians or mathematicians, they always actually tell me this thing that, you are not, you don't belong from our class. That's why might be the problem is happening.
No, Shami, I'll tell you, I know I have the best data analyst I've seen. The best, I think, she is actually an econometrician.
Okay.
So I don't think just being a econometrician is going to disqualify you from data analysis. In fact, the two best I've seen, data analysts I've seen in my career, none of them were statisticians. Sometimes actually being a statistician is more of a hindrance for reasons Shayan actually pointed out in his presentation than a help actually. Because you get set, you are oriented to solving a problem in a particular manner, and that reduces your creativity. So being an econometrician doesn't hamper you in any way.
Thank you very much,
others
sir.
ask questions.
Thank you very much, sir. Sir, my last question for this session to Honorable Chirag Gupta, sir. With kind permission from the Honorable Coordinator, sir, may I please?
Yeah, okay.
So thank you very much, sir, for allowing me. Sir, I am quite fluent in Python or MATLAB. So I did my postgraduate diploma from Bonn University, Germany, and on data science. And I learned actually about data science, machine learning, and artificial intelligence. And out of my own, actually, I got the access to some good materials. So I learned about real-time analytics through Kafka, as well as with Spark. But sir, I'm really struggling to learn about Hadoop quite well. So would you please be kind to me so that I can email to you, and you please be kind to provide me some good materials on Hadoop so that I can learn them very well. Thank you very much, sir.
That was for Chirag.
Sorry, I was speaking on mute. So I was saying like, yeah, sure, you can connect to me. I may not be the best Hadoop guy to answer, to guide you that, but definitely can give you some of the pointers where you can learn the Hadoop.
Okay, thank you very much. Thank you
Yeah,
very much.
and it's very broad spectrum of Hadoop, so you need to be a little particular.
Sir, I need to work in the field of financial and econometrical big data. Okay, so
sure. So, so that would be good if you can directly email it to me so that we can have a discussion.
Well, okay, thank you very much, sir. Thank you very much.
Thank you, Shamit. Yeah.
Okay, so if there are any other questions, so if there are no other questions or comments, then on behalf of the organizers, I would like to thank the 4 panelists once again. It has been a very nice, organized, and fascinating session. Thank you, Diptendu, Chirag, Shayandev, and Orin. And as we
our pleasure, Devuji.
Yes, Shayandev. Yes.
Thank you so much.
No, I was saying that our pleasure. Thank you.
And as we formally close this session, we are also coming to an end of this conference, this year's edition. So Kiranmoy, would you like to do the honors?
Yeah, so I first want to thank these 4 speakers for sharing their experience and actually encouraging the participants, because for quite a long time, our students, our participants, they wanted to hear more about the industry. Unfortunately, what happened, they only come to know about the industry when they come for the recruitment. Apart from that, they really don't know what is being done in where, and who are the seniors who are doing what and all this exposure, because I have received many emails this time complaining about why these things did not happen before. Then they are saying that we could choose our career, we could go in the right way possibly. So thanks for guiding the participants. And of course, with this, we want to thank all the speakers for all the 5 sessions that we are having in these 2 days, and all the participants for your patience, for questioning, for clarifying the things, for understanding it in a better way. So hopefully by next year, we should be able to do it physically, but if not, then we have to go like that. But definitely we'll continue this thing in future. So I hope you will have active supports and participations by which we can continue this wonderful 2 days event in future too. So thank you very much for your participation. Thank you very much for your cooperations, and thank you very much for everything. So please stay safe and take care of yourself.
Thank you.
Thank you.
Okay,
Thanks,
thank you
everyone.
all. Take care.
Bye bye.
Bye-bye.
Bye-bye.
Take care.